everyone. We are now working on the back of the worksheet that says Ideal Gas Law Practice. We did numbers 1 through 5 in class. Now we are going to do 6 and 7 together. The difference about 6 and 7 is that we are doing reaction problems. So that means that stoichiometry is making a triumphant return. And that means if we're doing stoichiometry, we need balanced equations. So when you think about our balanced equations in this example, number 6 on the back, it says when zinc reacts with HCl. So these are going to be problem equations from the past. So we're going to have zinc plus HCl. This is a single displacement reaction. The zinc will replace the hydrogen. So we'll have hydrogen by itself. And then we will have zinc chloride. We need to balance it still, and this balances it for us. So you need to have a balanced equation no matter what for sure. In this case, we'll have the same balanced equation for number 6 and 7. So we will not go back and rebalance an equation for number 7 because we'll use the same equation. The thing for any reaction problems is that the thing about them is that you will solve for moles first each time. So you can look at it and see what you have for information. In number 6, we have enough information to solve for moles using PV equals nRT. So I have PV equals nRT. If you don't have enough information, then you're going to have to do stoichiometry first. So I have PV equals nRT, and I can solve for moles. So I'm going to just start plugging in. So my pressure is 722 millimeters of mercury. My volume is 4.50 liters. Remember, that's this gas right here. We are wondering about the grams of zinc. So grams, we don't know what that is. Zinc is not a gas, so we can't apply it to the ideal gas law. So we're going to figure out the moles of this hydrogen gas and then use stoichiometry to figure out the grams of this zinc. So we're using PV equals nRT. I don't know my moles of gas. My R in this case is going to be 62.4. And my temperature is going to be 30 plus 273, which is 303. All right, if I solve for N, I will get 0.1718 something. Keep that all on your calculator. And that's moles of hydrogen. All right, in reality, I have 3 sig figs everywhere. So in reality, I only have 3 sig figs, but I'm going to carry that number through. Now we're using stoichiometry. I need to go from moles of hydrogen to grams of zinc. That means we need 2 conversion factors. So I'm going to start that equation right here, 1.1718, because I have more significant figures. I need to get the grams of zinc. Grams of zinc from the periodic table, 65.41. For every 1 mole of zinc. I need to cancel moles of zinc here. I need to cancel moles of hydrogen here. My zinc has a 1 in front of it. My hydrogen has a 1 in front of it. When I multiply through, because I'm not dividing by anything because there's only 1s on the bottom, as I multiply through, I'll get an answer of, I'll put it up here, 11.2 grams of zinc. So we are using ideal gas law to solve for the moles of the hydrogen in the first place, then taking that moles of hydrogen and solving for the mass of the zinc. Zinc is not a gas. You cannot apply the ideal gas law to it. Number 7. How is number 7 different? Well, we are looking for moles, or looking for liters of hydrogen in this case. We don't have moles. We can't use the ideal gas law first. We have an amount of the zinc in this case. So I'll rewrite the equation quick. So this is what we're wondering about. Don't know that. We do know 14.5 grams of the zinc is reacting. So what we're going to do is do the stoichiometry first in this case. So we're going to again solve for moles of a gas, but doing the stoichiometry first in this case because we don't have liters of gas. We don't have enough things in PV equals nRT to do that. So we're going to go ahead and solve for moles of the gas. In this case, the gas is hydrogen. We can only use the ideal gas law with gases. What else goes where? Here's grams of zinc. This is going to be 1 mole of zinc. Moles will cancel again. Again, it's a 1-to-1 in this case. This is 65.41. If I solve for that, I get 0.2216. I'm going to put dots there indicating I know there's more significant figures. In reality, I only have 3. So I have 3 significant figures because this number has 3. Now I have moles of hydrogen, so I can solve for the volume of the hydrogen. And I'm going to do that using PV equals nRT. So it's the reverse of the last problem because I have different things given to me. So I have PV equals nRT. I can solve for my volume. And we'll go ahead and set up the equation like we did yesterday. Start plugging things in. 0.2216, and keep that whole number in my calculator. Moles of hydrogen. My pressure is in millimeters of mercury, so I'm going to go ahead and use 62.4 as my R. My temperature is going to be 293, and my pressure is 760. So I have 3 sig figs everywhere. As I put that into my calculator, my answer, I'll just set over here because I know I have space, ends up being 7.59 liters. Check that. Bad answer key. The answer is 5.33 liters.